Hello, everyone. Welcome to this intro webinar from Ouster. Uh, Today, we're going to be giving you an introduction to our company, talking about some of the key markets that we play in, and talking a little bit about our technology. Uh, First, just a quick plug. We have a series of webinars from last year over the summer and into the fall that go through a lot of the technical details of our technology. So covering our specs to our VCSEL and SPAD architecture. And if you're interested in that, please do visit our website. Those webinars are all accessible there, and you will learn quite a bit more information on those. So with that, we're going to kick off this webinar here today. Again, my name is Tom Gray. I'm the Director of Product Marketing here at Ouster, and joined by Sam Chan, who's on the product marketing team with me here. So today we are going to cover this in two big sections. The first section, I'm going to talk about Ouster's digital LiDAR technology, the markets that we play in, and why we designed our sensors the way we did. And then Sam's going to take you through some of the use cases we have in these different industries and some of our customers and some of the cool things that they're doing. One quick administrative note on this webinar. Unlike past ones, we're not taking any Q&A today. But if you do have questions, please don't hesitate to reach out to us at lidar@ouster.io, and we'd be happy to answer any of those questions. So with that, let's get started. So first off, here at Ouster, we build digital LiDAR. Digital LiDAR, which we'll show a video on in just a minute, refers to how we architected our LiDAR sensors using a VCSEL and CMOS SPAD chip. And what we've done is we've taken a lot of the different components that you may find in other LiDAR sensors and integrated them onto those two chips. We've put all the complexity into those pieces of silicon. And what that allows us to do is use a common set of chips for all of our sensors to create a suite of sensors that can be deployed across many different applications. So what you see here are four different markets, our four key markets that we play in. We have industrial, smart infrastructure, robotics, and automotive. Across those four markets, as we scale, we truly believe that LiDAR is going to become ubiquitous and will be on every moving object on Earth. These four industries cross huge spans of our economy, essentially our entire supply chain, as well as all of our transportation infrastructure. All of these services in our lifetimes, we expect that they will be automated. They will be safer and more efficient for everybody, giving us all more free time to do the things that we love rather than either getting to and from locations or shipping things to and from different places on Earth. So the opportunity here is huge, as you can see from the numbers here on the slide. But just to kind of give you a sense of what we're really talking about, I've got a set of customer pictures here that we've been sent over the last 6 months. You'll see a range of applications here, just to really highlight how diverse the set of things our customers are doing really is. Up in the left, everything from automated snowplows to monitoring a subway system to autonomous buses, agriculture and mining automation, and even warehouse and factory automation. These things are happening today, and these applications are real, and they will be entering our daily lives more every single year. So the sensors that our customers are using to deploy these applications, we have three different options. We offer a wide field of view OS0, a mid-range, all-around, kind of multi-purpose OS1, and a long-range OS2. These sensors are all based on the same digital LiDAR technology. They have the same CMOS ASIC inside. And what we do is we customize these with different optics to adjust their range and field of view. So you'll see that reflected in the statistics below, where the wider the field of view, the closer the range comes, but those are generally for, the OS0 is great for warehouse applications versus the OS2 is ideal for things like highway autonomy. So with that, what we're gonna do next is I'm going to show you a quick video of our founder and CEO, Angus Pacala, talking through what we do is we show you the inside of an OS0. But this is truly the inside of essentially all of our sensors, and walk through some of the technology.
This is the OS0, one of our newest sensors. Inside is the key to everything we do, our digital Lidar module. It's small enough to fit in the palm of your hand, and yet it's extremely high performance. Instead of hundreds of discrete analog parts, it's made up of 4 key components. Custom lenses that define the sensor's range and field of view just like a digital camera, a patented micro-optical system that increases performance by orders of magnitude, a high-efficiency laser array, which integrates all of our lasers onto a single semiconductor chip. Last and most important is our Lidar system on chip. This piece of silicon uses SPAD photon detectors capable of counting over 1 billion photons per second. Our digital Lidar architecture powers all of Ouster's products.
Great. So I'm going to pass off to Sam here, who can walk you through some of the customer applications.
Awesome. Thanks, Tom. So at Ouster, we're not only building digital LiDAR, but we're building the eyes of autonomy. And so today, we're going to be diving deeper into just how Ouster's digital LiDAR is enabling safer and efficient autonomy across our 4 markets: automotive, industrial, smart infrastructure, and robotics. So starting with automotive, today, LiDAR is most commonly talked about in the context of automotive. And our customers in the automotive industry are either developing self-driving technology for driverless mobility or freight applications, or they're OEMs developing ADAS, which is advanced driver assistance systems for consumer vehicles. And for a fully autonomous vehicle, which is described as having level 4 or 5 autonomy, to be truly autonomous, they do require a suite of sensors for redundancy. And at Ouster, we designed our digital LiDAR architecture to be flexible to fit the short, mid, and long range needs, as well as the various field of view needs to provide for the suite of sensors. So for example, as illustrated on the left, you see a front-facing long range LiDAR that's used to see the road ahead, and a mid-range LiDAR placed on top of the vehicle for mapping and localization, and finally, a suite of short-range LiDAR sensors around the edges to identify potential risks that are immediately around the vehicles, such as a cone or a curb. And so to illustrate the critical role that LiDAR plays in autonomous driving, we'll like to introduce Plus, a leading developer of automated truck technology. And back in 2019, Plus made history as the first ever to deploy a level 4 autonomous truck on a cross-country journey in just 3 days. And through that, Plus has demonstrated the safety, efficiency, and maturity of its autonomous trucking systems. And today, they're preparing to scale globally. So to illustrate this, let's hear directly from Tim, who is Plus's chief architect, on why they selected Ouster as the near-range LiDAR provider for its automated driving system.
We are on the cusp of an autonomous revolution. I have 2 children that are 8 years old, and I believe by the time they're ready to drive, they won't need to drive at all. There are 3 key developments that are coming together right now that make it practical to deploy autonomous driving. The first is very high-power computers. The second is deep learning, and the third is high-resolution LiDAR. Plus is applying level 4 autonomous driving technology to trucking today. Trucking is a really interesting use case because trucks are really big. Trucks do a lot of work. You can increase the utilization of a truck to 24 hours if you can automate it. We're deploying our system in the US, China, and Europe at large volume. We'll have thousands of trucks on the road by the end of this year and tens of thousands of trucks by the end of next year. So we need partners that are ready to scale with us. Ouster is absolutely ready to scale. They are able to manufacture these sensors with high reliability and all the features we want at production volumes with production pricing. One thing that many people don't realize about trucks is just how big they really are. You can hide a car next to a truck, and it's very hard for the driver to see it. The reason LiDAR is so important for autonomous driving is because it tells you the occupancy of space, a very simple direct measure of whether you can drive there or not. When driving a truck at highway speeds, if there's something very far down the road, you still have some time to react to it. But if there's something close to you, you have to react instantly. That's why we try to keep a cocoon of perfect perception directly next to the truck, and that's why the Ouster Lidar is a key ingredient in our system. The wide field of view and the broad opening angle on the OS1 sensor is an absolutely perfect fit for our trucking system. It makes it possible for us to have zero blind spots anywhere. The high resolution of the Ouster Lidar is absolutely critical for our perception system. When it comes to Lidar, there is no range without sufficient resolution. Our system needs to be able to make decisions based on the sensor data that it's getting. The more points we can get on an object, the more confidence we have. The effective range of the Ouster sensor is best in class. We don't put Lidar on the truck just because it's cool. We put Lidar on the truck because we can't afford to make any errors in perception. We need our system to be absolutely perfect. Ouster has put Lidar on a chip, and they can actually take advantage of Moore's law. They're shrinking the components, and they're doubling the performance every year. At Plus, we've tested nearly every Lidar available, and the Ouster Lidar have the lowest failure rate. If you want to build the technology of the future, Ouster is able to meet that challenge.
Awesome. As Plus is making long-haul trucking safer, cheaper, and more comfortable, Ouster is proud to serve as a technical partner to make higher levels of autonomy also safer and more efficient as we prepare to scale to tens of thousands globally in the next few years. Moving on, the second segment that we'll be covering today is our industrial market. And our customers in the industrial market really span from manufacturing to mining to factory automation, which is what we're showing on the slide here, to drones. And in many of these applications, customers are operating either very capital intensive equipment or larger slowing moving equipment within tight spaces. And Lidar is playing a critical role in this to enable machine autonomy and ultimately improve not only efficiency, but also worker safety. And so as illustrated here, any single piece of machinery typically utilizes multiple Lidar sensors, similar to what we saw with the automotive example. And so again, for example, a mid-range Lidar is placed on the top of a mining vehicle for mapping and localization, and multiple short-range Lidar sensors might be placed around the edges to help identify potential risks that are immediately next to the vehicle. And regardless of the specific sensor used, we believe that our industrial customers really value this combination of high resolution, range, small form factor, and reliability of our sensors. And for example, a top 10 global railway operator is using an easy aerial autonomous drone that's outfitted with a mid-range OS1 Ouster sensor. And this operator is using the solution for highly detailed inspection and mapping of miles and miles of railway. And this data is then processed using Ardenna's AI-based software that provides critical information like the rail health, the distance of the railway, and really centimeter level information that operators can then use to make decisions around maintenance and repairs. And what this data does is it augments a typical human inspection and delivers this new level of detail that was previously only available with much more expensive solutions. And ultimately, this allows operators to provide safer conditions for its workers, provide more accurate results, and save on a lot of costs. The OS1 is ideal for drone-based applications for several reasons, as seen on the screen. First, Ouster's high resolution is ideal for precise 3D modeling of complex infrastructure. We're capturing millions of points per second. And what this means is operators can survey the same distance in less time compared to other sensor alternatives. Additionally, as we kind of covered in the introduction, our digital Lidar architecture reduces the component count by thousands. And what this means is we're reducing the number of potential points of failure, which results in lower costs to our customers and a more reliable Lidar which is something that is absolutely critical for moving applications. Third of all, at just 447 grams, our OS1 and OS0 sensors are some of the lowest weighing digital LiDAR sensors on the market today, and therefore can be integrated easily onto any drone application. And finally, what makes our digital LiDAR so unique is it's really designed to be continuously upgradable through firmware alone. So for example, we released firmware 2.0 back in December 2020. And with that, we introduced a new functionality known as standby mode. And with standby mode, customers can place their sensors in a sleep mode, which then reduces the power consumption and allows the customer to optimize the power consumption of the application and enable longer flight times. And so Ouster's partnership with Easy Aerial and Ardena in the railway market is just one example of how drones are really disrupting the industrial industry. We're seeing aerial-based inspection become ubiquitous across other industries as well, such as oil and gas or nuclear cooling towers. And we're really excited to deepen this partnership as we continue to work with this diverse array of industrial customers across all of these use cases. Moving on, the third segment we'll be covering today is smart infrastructure. And our customers in the smart infrastructure market are using LiDAR sensors for monitoring and analyzing of all road users, from vehicles to pedestrians to bikes and scooters. This then allows our customers, whether they're federal government to private corporations, to build applications around perimeter security, around road user safety, and around roadway efficiency. And we believe that digital LiDAR is ideal for these applications because it augments a lot of areas where traditional cameras may struggle, such as in low light conditions. Additionally, LiDAR doesn't provide any facial recognition information, and so it can still protect the privacy of citizens while having the benefits of safety and efficiency. As an example, one of our smart infrastructure customers in Europe is really leading the way as it prepares for the widespread integration of connected and autonomous vehicles. This effort is led by Aachen University in Germany in partnership with the German federal government and a host of other private partners like Ford Mobility. And the goal of this project is to systematically test automated vehicles that are operating within a connected traffic infrastructure. And with these learnings, the end goal is to deploy a lot of these connected infrastructure and automated vehicle functions in the field. And so as part of this 11 million euro project, over 100 Ouster sensors will be integrated across 60 connected infrastructure units, as shown on the left in this diagram. And in the first phase of this project, Ouster LiDAR sensors and the cameras are going to be recording data of vehicles and pedestrians across 3 test sites, covering urban, rural, and highway environments. And the OS1 sensors augment camera output by providing a 360 horizontal field of view and providing accurate data across variable lighting and weather conditions. Because LiDAR sensors don't rely on ambient light, our sensors can accurately capture traffic through day and night, which is extremely critical given that majority of accidents actually happen at nighttime. And with all of this highly precise data, Aachen University researchers can then develop classification and tracking algorithms. And in future phases of the project, the data will then be transferred in real time to connected vehicles on the road. And in the second phase of the project, aggregated data of the traffic and environment will be used to create digital twins, which is shown here on the slide. These 2 examples are kind of simulations that researchers can run on different vehicle and infrastructure scenarios. And from there, they can take the learnings from these simulations and actually test the vehicles in the field. And so Ouster is proud and excited to partner with Aachen University to support such mission critical research and ultimately make connected and autonomous vehicles safer and more efficient. Last but not least, the segment we'll be covering today is our robotics industry. And our customers in the robotics industry are generally designing and producing small, mobile, humanless vehicles. Our customers are using LiDAR sensors for things like autonomous navigation, collision avoidance, mapping, and really provide a host of services that range from last mile delivery to street sweeping. And we believe that our robotic customers really value this combination of high resolution, wide vertical field of view, and ruggedness and reliability of our digital LiDAR sensors. So as an example, at the forefront of autonomous delivery innovation is Serve Robotics, which was formerly part of Postmates. What they realized was that because so many deliveries happen within dense urban areas and very short distances, autonomous rovers are actually proving to become a very efficient and more environmentally friendly solution. So let's take a look. So as you can see here, Serve, an autonomous delivery rover, is the world's first socially aware robot and can be found busy today delivering goods in San Francisco and Los Angeles. LiDAR plays a critical role in enabling Serve's autonomy by being the eyes of the robot. And Serve's built-in algorithms use this LiDAR data to make critical decisions like the best way to get to a customer, how to navigate unexpected roadblocks, and how to react with incoming pedestrians. And a mid-range sensor is ideal for robots like Serve because it gives them enough time to detect and react to obstacles up to 100 meters ahead. And because customers are ordering day and night, rain or shine, Ouster's industry-leading reliability and ruggedness ensure that our LiDAR will sustain all weather, all day performance. And we're really excited to partner with innovative customers like Serve Robotics to really scale this deployment to major cities and also make autonomous robots more intelligent and safer with 3D vision. So hopefully that gave a taste of just how Ouster's LiDAR sensors are fueling the autonomous revolution. We're seeing a growing demand of low cost and high performance sensors. And at Ouster, we envision a world where LiDAR is going on every moving object, every intelligent infrastructure on Earth. And we believe that our simplified digital LiDAR technology will enable us to achieve just that. So if you're interested in learning more about our LiDAR sensors and how we can help you accelerate your projects and automation, we'll love to hear from you. Please reach out to us at lidar@ouster.io. And thank you so much for attending our webinar today. A recording of this webinar will be emailed to everyone who officially registered. Thank you.